We're almost there.
Yep. Days away from graduation.
Yeah. And you graduate at the end of this semester?
Austin and I are in the same semester. We
Cool.
graduate this semester.
Hey, congratulations.
Yeah, well, we'll see. Yeah.
Speaking of Austin, have you heard from him today?
Not today.
Hello.
Hey, how's it going?
Yeah, speaking of the devil.
Speak of the devil.
Good. How are you guys?
Not too shabby. How about yourself?
I am super happy right now.
Really?
Yeah, I just got done with one of our exams. I got like by far the best grade I've ever gotten on an exam. So,
Nice.
according to me, that is.
Nice.
Makes me happy.
I thought I did the worst on that test, but I came out way better than I thought I did. That was a very
Yeah.
good answer.
There was like a lot of like funky questions, and I was like, I'll go with this answer. Yeah.
Yeah. Mhm.
So,
Hey, my computer's running kind of slow tonight. I think I'm going to turn off my video if that's all right.
that's fine. I actually won't. I'm still on campus. I'm here. I have to be here until my wife's done with her presentation stuff. She's doing all these presentations for one of the classes. Um, and my computer's going to die in probably like 30 minutes
Okay.
because I've been studying, using it all up. So
Okay. Well, let's blow through this. Let's get it.
yeah, but I am prepared.
Cool. Well, that makes one of us. Looks like Jared just joined us. Jared, can you hear us? Jared Ferguson. I think he's got his camera turned off too. Should we jump into the assignment?
Yeah, sure.
Okay. So the 5 assumptions. Let's see. I'll read that. What are the 5 assumptions to check in order to do inference for simple linear regression? How do we check these? So there's 3 assumptions that we can check for. 2 of them we can't. So we check to see if there's a linear relationship, and we do that. We check that on the scatter plot. We want to see a hot dog.
I don't know why they call it a hot dog because it never looks like
No.
it.
Yeah. Couldn't they just say it's close to the line? I mean, I think
Yeah.
once you see a couple, you know what it's supposed to look like. The second one is the error term is normally distributed. So you look at the QQ plots. On the linear relationship on the residual plot.
Oh, Jared. Jared. Are you there? No, Jared is not there. Oh, he is. Wait,
Which Jared?
other Jared.
Cardnet
Um,
or Ferguson?
he stepped out. We were like trying to figure out why our we were doing this in like QQ plot. Jared.
What?
Okay, so remember when we were going through the stuff and like the QQ plots where like we just assumed that it was correct because everything else is correct? I just realized you have to put them in the chronological order.
Chronological order.
Remember, don't you have to order them from like lowest to highest?
Yeah,
The Q
yeah, we did
plots?
that, didn't we?
No, I don't think we ever did. I think we just plugged the data in.
You told
Because
me
we were
you did.
struggling just to get it over.
Yeah, you said that you were able to somehow like copy over the data and through some magical way, sort it from lowest to highest. I wasn't able to do that with mine.
Yeah, I never ordered it. That's why it looked so funky. Okay.
Interesting.
Now we know.
Okay.
Okay. Yeah, QQ plot.
So the third assumption is the variance of the terms is constant. You do that through the residual plot, and you're trying to avoid the megaphone shape. You want everything to look all random. And then the two other assumptions, you can't check for them, but you want to see that the observations are independent, which I guess you just assume if you're given the data. And the x's are fixed and measured without error. So, in other words, the x's are known constants.
Mm-hmm.
So you can't check for those two last ones, but you're supposed to know that they exist, I guess. So that's number one.
Number 2. In the formula, y plus beta O plus beta 1, x plus e, state which each symbol stands for. Well, I personally just keep looking at this. I always convert it back to like a linear regression formula, so just y equals mx plus b, and plus e, I guess. So your b1 is going to be your slope, and your bo is going to be your y-intercept for your data. So, and then e is the error term, so it's the number they give you.
Sounds good to me.
Okay.
So moving on to part 2.
Check the 5 assumptions for conducting a linear regression on the data. List 5 assumptions below and explain how you checked the assumptions, include chart graphs where appropriate. So we're going to use the Gharial crocodile data. This is where it gets a little hairy.
Yeah. So do I still have it up? No, I don't. I have the homework stuff.
I'm opening it up now, but everything's running slow tonight. I don't know what my deal is.
I'm doing the linear regression thing still, right? Yeah, so the head length and the body length, I think that. So the head length is the independent, the body length is the independent. Okay. Now we have to check the results.
Okay, you ready for number 1?
Yep.
Okay, so check the 5 assumptions. For some reason, the school web page keeps falling up. Okay, so I guess the first of the things would be to check the x and y relationship, see if there's linear. So you just make a scatter plot, and when you do that, you get a pretty good linear. I mean, if you have a trend line going, they fall pretty close to it. And if you look at the R value is 0.986, and that indicates that it's fairly close to the line.
All right.
And a positive slope or whatever. And then I did make a QQ plot for this, did it? No, not for this, just kidding. The other one. But if you make one, it ends up looking really close to the line. There's a little bit of deviation, but it's still normally distributed.
Yep.
And make sure to order them from ascending when you do plug on all your data points into the QQ plot.
Otherwise, it looks wonky.
Yep. And you plug in the x variables, right? Or is it the residual?
Into
the QQ. You plug in your residual into the QQ.
Right.
Yeah. Because you want to see if the residual are varied. Whatever. Okay, and then next thing is to do the residual scatter plot to see if there's you don't want to have any kind of pattern with it. You want them to be all over the place. And this is really annoying at first to try and figure out, but we got it to work. Yeah, you just highlight just the residual, go straight down, get them all. And they end up looking kind of like a QRS heart monitor EKG thing.
Oh yeah, they kind of do, don't they?
Yeah. So, and we just assume that the things are, let's see, what was the last? That they're fixed and measured without error. And we're assuming that the values of y are independent.
Oh my gosh, Austin, I figured it out. I figured out how to do the Q to Q.
Yeah, it just...
Well, you know how you were saying, like, you figured out some way to, like, copy-paste and, like, copy-paste again and again? Well, yeah. Apparently you can just paste the value. Did you know that? Dang it. How do you tell me these things, Austin?
Well, that's how I did it.
For some reason, I thought you did it some other way. It was, like, really confusing. I was, like, too tired to know what the heck you were talking about.
I copied the values to a separate cell so that I could just copy the separate cells over to the QQ.
And then you just sorted them from lowest to highest?
Well, before what was happening is that we would just copy the column, copy and paste the whole column of the residuals, and it would copy the formulas for each of them.
Oh.
Error because it didn't have anything on that Excel sheet with the formulas, and so it was all janky. So that's what we were trying to figure out.
I see.
So, and then let's see what's left on this thing. Oh, number 2. You want to take that?
Sure.
You guys?
Test if there's a linear relationship between the head length and the body length. So we want to state the null and alternative hypothesis. So on that, and the null is B equals 0. I'm sorry, B1 equals 0. Or actually, it's beta 1, isn't it?
Mm-hmm.
And then the alternative hypothesis is beta 1 is not equal to 0.
Beta 1 is the slope, right?
Beta 1
Beta 1
is the slope, yep.
which we want it to be not 0, or 0 means that everything's exactly on that line,
Right.
on the trend line.
Well, if the slope is 0, it'd be horizontal.
Yeah,
Yep.
exactly. Or yeah, it would be a 0. If it's positive, then it's a positive regression. Negative, we're saying that that's not possible. It's
Right.
always going to be like significant, I feel like.
Yeah. And then B is that the alpha value equals, we're given that, aren't we? Isn't that 0.5?
It didn't really say, but I'm assuming it's almost always.
It's almost always 0.5, so that's what I'm going to assume. The test statistic, let's see what we got here. Test statistic I have is that's R, right? It's point. Wait, right? 0.90. No, the test statistic is 22 point. That's the t value. That's 22.675. And then the p value is mu hat, isn't it? No, that's not right. Why am I?
Yeah. So there's some main values that all we need to look at is, can you see my screen?
I can now.
These things are the only things you really need to worry about.
Yeah. So, oh, geez, right there. It says p-value.
Yeah.
Okay. Oh, that's what it was throwing me off. Okay, so it's 5.0835 times 10 to the negative 13. It's pretty small. So
basically 0.
Basically 0.
Yeah. And that's because the chance of something being exactly on that line is impossible, pretty much.
Yeah, nearly impossible. So since it's way less than 0.05, we reject the null. And since we're rejecting the null, we say that we have sufficient evidence. Let's see, how does this stated? To suggest that the true regression of slope B sub 1 is between the up. No. I'm sorry, I'm reading the confidence interval. We have sufficient evidence to suggest that there's a linear relationship between the head length and the body length of the crocodiles.
We create a 95% confidence interval for the true slope of the regression line and relating that. So that's
just right there.
Yeah, that's given. We got 6.704 on the lower and the upper 8.096.
Whoa. No, it's weird. I got the SPSS numbers on my, even though it says it's, I guess Excel should give you the other ones.
I think that means it shouldn't say Excel gives you these numbers.
Yeah, I got the SPSS numbers as well.
You've got corrupt SPSS files.
Well, let's get to this homework.
Yeah, let's get into it.
15 minutes left in my battery. I don't think the quiz will take more than 15 minutes, though. It's pretty simple.
All right, we ready?
Yeah.
Let's do it.
You just need the math efficacy data.
Which one?
The math efficacy. It's like the one there's like, oh, where you had to like switch the values on the one sheet.
Oh.
Super annoying.
Oh, is that inside the quiz? I don't see it.
You had to download it somewhere.
Yeah.
Or pull it up from where it was before.
Yeah. math self-efficacy, right?
Yep, that one.
All right. The true linear regression is y equals b null not plus b1 x, where b naught and b1 are known. What are the null and alternative hypotheses for b1?
Just the third one.
Yep.
Equal to and not equal to.
Yep.
Okay, I'll take the next one.
Okay.
Residual is, I think it's going to be the second one, is the difference between the observed value y and the value predicted by the regression line. It's like the distance from the point from the line.
Okay.
That's how I always remember it.
Sounds good. Jared, you want to do 5?
Sure.
Are you on?
Yeah, sorry. My daughter just got her first tooth to poke out, so now I'm like constantly going back to the crib to take the bottle out.
Oh.
Let's see. A plot of residuals supports using linear regression when the residuals look normally distributed with zero mean.
So the last one.
Yeah.
Okay, I can take the next one.
All right.
Okay, compute the residual for the self-efficacy data we're using software, using the confidence data, and I actually have that on mine. I just need to back up to where
Okay, so confidence is the explanatory data, so that's column 1, right? Or do I have that backwards now?
Let's see. You have to swap the
Yeah.
variables again, so you have like
Right.
4.34 as like your top one on the left, and then 50 is your
Right.
top one. And I think it's the first one, the residual, or the residuals are between negative 40 and 25. That's the only one that makes sense with the doing the residual scatter plot.
40 and what?
Negative 40 and 25.
I'm not sure I understand what that means.
So if you take your residuals, highlight all of them, and then make a scatter plot of them, it will give you like a number. And if you look at the upper values,
Oh, okay.
the upper value is about 25, and the lowest value is about negative 40.
I got you.
You can see it on my screen. That
Yeah. Okay, I got it now. Yep, I can see it now. Okay. Okay. Let's see. Based on the QQ plot for these residuals, what can you say about these residuals? The residuals are clearly not normal. They look right skewed, or they're fairly normal.
I have that up actually, because I was trying to figure out how to do it, and I have it. No, not right there. Not there. Where'd it go? There it is.
This is what my QDQ looks like.
Well, that looks fairly normal.
Awesome.
Is that what yours looks like?
Just like almost a straight line.
Hey, Jared.
Hey, sorry about that.
You're back. No worries.
Yeah.
We're just doing the quiz.
Okay.
We're on question 7 now.
Okay.
So do you want to back up and we'll go over the?
Sure. That'd be
Okay.
awesome.
Yeah,
Thanks.
Jared's or not Jared, but Austin's battery's dying, so we're gonna hustle through this.
Okay. Sorry.
No worries. So 3, we have the third one. B equals 0 and not 0.
Right.
And a residual is the second one, the difference between the observed value and the value predicted by the regression line.
Okay.
And 5 is the residual, the bottom one. The residuals look normally distributed with 0 mean.
Okay. Cool.
6 is the first one. The residuals look like they're between about -40 and 25.
Okay.
And 7 is the residuals are fairly normal, the bottom one.
Okay. All right.
So now we're up to 8, using software to
Right.
create. Oh, sorry, go ahead.
Oh, I was just thinking this one is really hard. I don't know the answer to this, or I don't know which one's completely to put.
We can tell you what we put.
Yeah,
Okay.
I have a feeling I know what it is, but
because we got it wrong. Me and Jared did this earlier, and we got it wrong.
neither
Wait.
of us put in the values that I thought were right.
None of. Okay.
So let's just go through it though as a group and see what we can figure out.
Okay.
Assumptions are satisfied.
Okay, given the scatter plot, so it's pretty much asking like, are the 5 things satisfied? Yeah.
Yeah.
Which I'm thinking it actually is, now that we figured out how to do
So-
the cube and all that stuff.
All right. So based on the QQ plot, it looked like there was a. I mean, based on the first plot, it looked like there was a linear relationship,
Yeah.
and they were normally distributed.
So,
Um,
and the variance,
I want to see that we should check all of them.
yeah, I'm thinking you check all of them. Because the QQ is the variance of the error terms is consistent,
yeah.
right? That's what it means.
Yeah.
I remember looking that up. And
Check
that,
them all, and they all look
And
okay, right?
And the other two, you can't verify, but we'd have to kind of assume they are. So
Yeah.
when you guys did it first, did you just check the first 3?
we did 1 and 2 and then 4 and 5.
Okay.
We missed, because our QQ plot was all jacked up because we didn't put it in order. So we're like, I guess that's not correct.
Oh, okay.
But now that we corrected it,
Yeah.
it looks nice and linear.
There it is.
Okay. So then we'll check all 5. Then number 9 is the B1 estimate for slope.
This is all plug-in stuff.
Did you get 12.725?
Yes.
And the confidence interval. 10.708 and 14.742.
Yeah, 10 and 7, or 10 and 14.
10 and 14. Okay, so that's the first one. All right. So based on the evidence using, so the p-value is super small. So we're going to reject the null because the value is less than a.
Yes.
Okay. And for a hypothesis test, if you reject the null hypothesis, what does it mean?
It means that there is enough evidence to prove that it's not 0.
Mhm.
Yeah, so that's
There's
3. Okay. All right. The dependent variable is the. Oh boy. Oh wait, that's on the other one.
Yeah, for the Grok data, you don't actually have to pull it up, I don't think.
Yeah. So that let's see. I get this backwards all the time. The head length is the dependent variable.
You're using the head length to determine
The body length. So the body length is dependent on the head length, so it's body length.
Yeah.
Okay. And the 99% confidence interval is 7 and 8. There's a, let's see, since the confidence. Ew. There's a 99% chance the confidence interval will contain the true value of B1.
No. That's what I thought.
Yeah, but since it doesn't contain 0, there's sufficient evidence to conclude that it's not equal to 0.
So that's the right one. I don't know why it's right, but that is.
Yeah, there's something about the wording on the second one that doesn't. That's not quite right.
Yeah. Since the confidence interval does not contain 0, there is sufficient evidence to conclude that P is not equal to 0. I thought you weren't supposed to have 0 in the confidence interval anyways, because that makes it invalid.
Well, in this case, the null hypothesis is about rejecting or not rejecting 0. So I think that has. I remember from the video there was something about containing 0. Or not containing 0.
Okay. Well, that should hopefully be 100%.
It is not.
Number 8.
Yep, number 8. I wonder if is satisfied by the data. I wonder if it's just the first 3 then.
It might be.
Yeah.
Because I guess the other ones can't be satisfied by the data.
Right. That is a trick question. That is sneaky.
Well,
Oh well.
Yeah.
well, next week looks like it is just prepping for the. Do we have a class thing, or is it just no? It's review.
Yeah, and we have one on Thursday too. Let's see. So we have 2 assignments, group assignments due this week, right?
I think I have the next one on the list, which is I need to look at it again. I forgot what it's called, but I know what I need to do.
Yeah, we have making inference and taking action.
Yeah.
So you're making inference, and Zach is taking action? Is that right?
Has anyone been able to contact Zach recently? He hasn't been at the group meetings.
He sent a notice that he's swamped right now and wasn't able to attend tonight, but that's all I've heard from him.
Okay.
I do have a question. It says, do we have to do anything for these individual assignments?
Yeah, if you go to iLearn, and down on the bottom,
The file projects folder.
yeah, in the projects folder, there's a sheet you need to fill out and submit.
For each step.
For each step, yeah. So since you're doing making inferences, right? Oh wait.
Yeah, he just has. It looks like there's 12 questions to answer for making inferences.
I thought those were 2 separate things. It looks like there's only one.
Oh, and take action.
Yeah, those are.
Huh.
Okay, well maybe maybe you and Zach can work on that one together then.
I guess, yeah.
List yourselves as co-authors or something.
All right.
The way that was listed, it was always listed as two different things. So
Yeah.
okay. Well, you okay with that? Maybe you can get with Zach and you can work it out.
Yeah, no, that's fine.
All right, cool.
Oh, it says making inference and taking action are combined assignments. It says it on the overview.
Oh, well, look at that. Okay. And any feedback yet on your submission, Jared? On describe the data?
I'm looking at it, and we don't have anything graded for it yet,
Okay.
but it's submitted.
Okay. Can you send me a copy of that so I know what data you submitted so I can work out on the PowerPoint with it?
Yeah, let me just download it real quick.
Okay, cool.
This stuff.
Yeah, and if you could send me a copy of that as well, that'd be awesome.
See, did I send you one? I think I did, because I think.
You sent me one?
Oh, Zach.
Oh, Zach.
I mean, Jared.
Oh.
You guys, I'm gonna head out.
All right. See you, Austin. Have a good night.
Yeah. See you guys Thursday.
Okay, I'll send you your stuff.
Oh, I sent one to Zach. Why did I do that? Well, I'll send you one too then.
Okay.
Hey, oh, here it is. Describe the data. Okay. I made it real pretty for you guys. Got some cool graphs.
Sweet. That's what I like to hear.
It's got nothing but don't accept anything less. Okay, compose to good. Ferguson. There you go. Add attachment. See how we started it. Right. Okay. Sending without a subject or a text. I think that's okay.
That's fine, me. All right, cool. Thanks, Jared.
Awesome. Thanks.
No problem. Thanks,
See you guys.
Good work.
Yep.
Bye.